So hello everyone and welcome back to another graphics card PCB overview video. I'm gonna say it first, there's going to be a follow-up video to this where I talk about what exactly is up with this card, because I wasn't so lucky this time. But for now it's only going to be the PCB breakdown of this here GTX 470 reference PCB. So this is the completely standard Nvidia model that, well, basically, you can see here. This is the blower PCB. And yeah, so first up, this is a GTX 400 series card. So of course we've got our Fermi core here. This is a GF100-275A3. It has 448 shader units. So it's basically the same core as the 560 Ti 448 that we had on here, because it has the same amount of cores. It has basically the GPU is the same except for the name. They also have the same amount of VRAM. This card has 1.28 gigabytes of GDDR5, Samsung in this case. Actually, all the Fermi cards, all 4 Fermi cards that I have had to go through here are Samsung, which makes me question if there is even anything else, because the BIOS has an entry for Hynix, but I've never seen a Fermi card with Hynix memory on it. So yeah, technically it could exist. I don't know if it actually does. So, but now for the interesting part, our VRM section over here, because this VRM is kind of different than the other VRMs we had before, because of course you've got these holes here. There's this huge blower fan that goes here with the stock heatsink. I don't have the stock heatsink here. This card came with an aftermarket cooler. It came with this thing right here. So yeah, the stock cooler is gone. But you can still see where it was. Like basically the stock cooler is just, you have a blower fan here, and then there's a fin stack over here, and the blower fan just blasts air through here, then out of the rear exhaust, and that's how the cooler works. It's really loud, not that good at actually cooling, but that's just what Nvidia ships up until the 20 series. So what we've got here is a 4-phase V-core, and this one is 90 degrees rotated to what you would usually see. Normally you have a VRM like this, with the inductors going like MOSFETs to inductors going into that direction, right to the GPU, because you want the most direct path for your V-core voltage. On here it's 90 degrees rotated because, well, you have to fit that big fan over there, so you obviously can't cram your VRM on this board like you would usually do. So they have it 90 degrees rotated. This V-core VRM is a 4-phase, and it is using all on semiconductor parts. So starting with the Pwm controller, which is on the back actually here. So this is our V-core Pwm controller. It is an on-semiconductor NCP5388. It is a 4-phase controller, and it goes from 100 kHz to 1 MHz switching frequency. I don't know which switching frequency the card is running right here. So yeah, it's probably somewhere in that range, probably 300 to 500 kHz, I would guess. Might be a little bit higher because it's just a 4-phase. If you remember, the 560 Ti 448 did have a 6-phase, and the GTX 580 DirectX 2 had an 8-phase. So this is pretty weak compared to that, and the MOSFETs are also not really the best. So this card actually has the same MOSFETs for V-core and VMEM. So VMEM is that one phase over there. And for the high side, you have I really don't know if you can, yeah, okay, you can see it. So for the high side, we have an on semiconductor NTMFS 4921N, and then for the low side we have 2 of the on semiconductor NTMFS 4946N. These are rated for 3.4 milliohm RDS on at 10 volts. These are running 12 volts, if I remember correctly. At least the Pwm controller runs straight up just from 12 volts. And from that RDS on value, I would think they run 12 volts, so it's going to be slightly lower than the 3.4 that they are rating for 10 volts here. I can't exactly tell you how low, because that is not a linear function. So it's probably going to be, if I'd had to guess, I would say something like 3.2 milliohm RDS on. But I could be completely wrong about this. So yeah, the RDS on is not the greatest. It's better than the low sides on the direct CO2, but the direct CO2 had literally double the amount for a similar core. Like the 580 core, of course, had 512 cores. This only had 448, but it's still a Fermi core, so they do suck a lot of power. Then also those low sides are rated for 100 amps. At 25 C case temperature, and then at 72 amps, if I remember correctly, at 75 degrees Celsius T case. So they can handle some, yeah, they can handle a little bit more current than most of the MOSFETs you would see, which makes sense because you've only got 4 phases of them. Yeah, but I can't really tell you anything more about the current rating. The datasheet wasn't really going into detail there. Like, I could find datasheets for all the components that I looked up on this card, which is nice, but pretty much all the datasheets were just one page and then a second page with 2 more bits of information on it. So there's not really a lot of information about the components on this card. Yeah, so that's your vCore MOSFETs. VMAM is using the exact same MOSFETs. And then VMAM has its own Pwm controller, which is this right here. That is an NPEC APW7165. It is a one-phase controller which is locked to 300 kHz switching frequency. So yeah, pretty basic. Like I wouldn't be surprised if it not even has an enable line or something. Like, it just runs. It just drives that one phase. Like, if it gets power, it runs, basically. Like, it only has 8 contacts. You can't do that much with 8 contacts compared to the, I think this has 40 contacts. Which is like this Pwm controller could do some interesting stuff, because I think, I'm not so sure, but the NCP 4208 on the 780 Ti PCB is an 8-phase, and that might have the same amount of pins. And yeah, on the 780 Ti that drives 8 phases. Here it only does 4, so you would have enough pins to do some fancy current balancing. But I don't think the 400 series does that. Like, there's just no power limit. Like 400, 500 series, like the 580 Lightning does have power monitoring shunts, but it doesn't report into software, so it doesn't really affect anything. Like, yeah, so these cards basically just don't have a power limit. And you can also really easily volt mod them up to 1.213 volts by just creating a custom BIOS. Yeah. So another thing that I have, like, that I've noticed about this PCB is all those capacitors. Here, there's 2 over there. If I remember correctly, these are tantalum capacitors. Like this plus marking, I think that means they are tantalum capacitors. I have no facts to support that. It's just because I have seen people saying these are tantalums, and I always pointed to these capacitors with that plus marking on them. So I might be right, I could be completely off on that. But yeah, whenever someone said these are tantalum capacitors, I basically saw these with the plus on them. So these are pretty nice, pretty expensive actually capacitors on here, and I think they are all V-Core. I'm not so sure. Like these are obviously for the V-Core VRM, but these over here could be VMEM. I'm not so sure. I could just check because I do have a multimeter now. I just went into the family workshop and went through my dad's old stuff, and I found a multimeter that's still working. Apparently it used to be very expensive, and he actually killed the 800 milliamp socket there. So yeah, we can test, because I have checked core resistance, which on this GPU is actually pretty low. It's like 600 milliohms or something. So we go in here to our ground pin on the 6 pin, and then we can... Doesn't get anything. Yeah, 0.6, 0.5, 0.7, that is V-Core. Or 0. Oh, that's too low. Okay, these might not be V-Core. Or I'm measuring something wrong here. Like, I could totally measure something wrong. This is the first card that I've played on with my multimeter. Or like not my multimeter, the multimeter I found that still works. Okay, let's just check. So this is ground. Let's just measure V-Core. Yeah, 600, 700 milliohms. Yeah, that's what I was seeing. I checked with the 560 Ti 448. Because first I thought the card had a short from V-Core to ground, because, well, that's pretty low. Like, but it's not like if I short these together you get like. Okay, those measurements are off. What is wrong now? Yeah, that's what I would. Yeah, 100 to 0 milliohms. Like, that's a short. Like, if I check the if I check that ground pin over there, that's quite high. No, it's going down. Yeah, so that's shorted together because both are ground. So our V-Core is not shorted to ground, obviously, because, well, if you short V-Core to ground, it should go up in flames somewhat. And it doesn't happen here. It's like I'm going to say more about this in the follow-up video, because that card is dead. It is dead. It worked for about an hour and then it was just dead. Like, I bought this thing for the heatsink, so I'm not really that disappointed, because I have enough Fermi cards to mess with. And this one is definitely the worst of them. Like, it did 840 megahertz core, whereas my 580s, like the DirectC 2 can easily hit 1 gigahertz. The 580 Lightning, which I haven't tested with a non-stock heatsink yet, that can do almost 1 gigahertz, and if I put it on water, it can probably do way over 1 gigahertz. Like, yeah, the Lightning will be better than the DirectC 2 because the PCB is just much better, and both are pretty close in ASIC quality, actually. Though the DirectC 2 can go higher in voltage, I think. I could mod that. I could totally BIOS mod that. So yeah, I don't want this video to get too long, because, well, story time is reserved for another video. This is just basically, yeah, I wanted to check the capacitors. I have the feeling that I'm measuring this stuff wrong. So, like, ground pin is this one. What is this? These are shorted together. So that's the ground side, I guess. Yeah, so this is V-Core. This is vCore. This is also vCore. Like these are obviously vCore because they are at the back of the vCore here. Nah. Why am I not getting... like this? Yeah, these are shorted together. Am I measuring this wrong? I think I'm measuring something wrong here. Like, let's check this one. What is this? vCore again. Okay, this one I guess too then. I think the probe head is too big. I can't touch the metal pad over there. What are these? Also vCore. Okay, so the tantalums are all vCore, I guess. And then another thing is those little SMD capacitors. Those are, most of them are actually like this row, and I guess part of this row are all VMEM. Like if I measure VMEM to ground, you get something like 64 ohms, I think. Yeah, 62.3, something around there. Like if I screw hole ground, you get 63. To ground pin, you get 68 something. I guess the connection is not that good. So around the mid 60s. And if I now measure one of these capacitors to ground, 62 ohms. That is vCore, and that is VMEM. This one too. And this one here also. And this one too. vCore again, VMEM again. Like VMEM. Also VMEM. And then these here, these give like a... no, that's also VMEM. And that's, yeah, that's the ground side. Yeah, like these are something else. These will give you like 400, like something around 300 to 500 ohms. I guess these little ones are, no, that's the ground side. I think these are also, yeah, these give you like 400. That's probably something else. These might be for, I guess that thing down here is the PEX rail. These might be connected to that, or it's something else. Like I have no idea what these could be. So yeah, you've got a lot of vCore tantalums on the back, and you've got a lot of VMEM like thingies on the GPU itself. So yeah, and also one more thing is these inductors over here. These are input filtering. Like that thing over there. This is not input filtering for PCIe. That is probably a buck converter for like the PEX rail, because PCIe input filtering is this one here. I checked with the multimeter. This is shorted together to PCIe power, and then these two are for the 2 6-pins. Like, yeah. And that's pretty much everything there is to say about this PCB. Like, it's standard Nvidia stuff. It's not that impressive. It's a 4-phase, and yeah, like I bought this card for like, for me it was a GPU cooler with a card attached, and actually I have to modify this because the standoffs are too big. It only fits Fermi cards with IHS on as it is right now, so I have to shave these down, or I have to buy the other compatible version of that base plate from Arctic. Though I don't know if that comes with standoffs. Because the spacing is correct, it's just that the standoffs are too large. Yeah, so whatever. This is it for the PCB analysis video. If you want to know more about this card, like me just rambling about it, what I did with it, because, well, it is dead. It is the first GPU that's officially dead. Like the 780 Ti Wind Force came back to life, so that's not dead anymore. This one is dead though, so it is like there's a fair chance that I killed this card. Like I would say it's a 50-50 that I received it broken or that I killed it myself. So yeah, if you want to more, if you want to know more about that, just check back for the follow-up video. These are probably going to go up together. So yeah, depends whether I upload these with my own internet, which is going to take literal hours, or if I just upload these on Monday when I'm in university and it takes literal seconds because that one has a gigabit connection. So yeah, so this is it for the video. Yeah, thank you all for watching, and I'm going to see you for the next time, I guess. So bye.